focus on asset management and preservation. That event also was sponsored by us, with AASHTO, and included participation from the AASHTO Subcommittee on Asset Management and the AASHTO Subcommittee on Maintenance. I believe you will find that peer exchange report quite interesting. We had some very good interaction and so forth. One of the bits of information that's included in there, we talked about development of asset management plans. For those of you who don't know much about the MAP 21 requirements for asset management plans, state DOTs are to develop asset management plans and must address as a minimum their pavements and bridges. They're encouraged to include other physical assets, such as traffic signals, etc. They have to have an inventory of those assets, condition. Do they have performance goals for those assets? And then looking at those assets, is there a financial plan, such as looking out 10 years on potential needs and funding for them? Managing these assets for the whole life? Looking at risk? And then developing investment strategies. I talk about this framework, which I was required by MAP 21, and as you go through the presentations today on the traffic signals, think of how this framework would apply as you may address these in your asset management plan, or if you don't have a plan, just managing these assets alone. Once again, welcome to everybody to this webinar, and let me turn it back over to Matt.
Thanks, Steve. So next up is Paul Olson from the FHWA Resource Center. So, Paul.
Thank you, Matt. And let's go on down to the next page. And where I'm kind of starting at is I'm going to talk about some of these issues here, and hopefully this is what the rest of the speakers will ultimately address. And Steve Gage talked about the influence of MAP 21. And lastly, think about the role you can play in asset management of your own, whatever you got going there. Next one. FHWA is still working to understand MAP 21 and to develop a rulemaking that will be required. I don't think anything official yet, at least not that I've seen. And the information that we're presenting here is subject to change, so it's something that you really should stay tuned to. Where I'm going to start here is over the last 6 years, we've been doing traffic signal operations reviews. And we've done, I think, 21 of them so far and talked to well over 100 different agencies. And in talking to these agencies, very few of them really know the value of the asset that they're accountable for. They haven't had time to even track it. Many of them have been underfunded and understaffed. And the people that have said they have asset management really only have an inventory system at best. And none of the folks are using asset management for long-term planning. In other words, there's nothing in the long-range transportation plan that says every 10 years I'm going to need to replace my traffic signal central management software. And most of them say, well, they don't have the time to do the basics, much less do this, or the money to do asset management. But in saying that, they're kind of missing the point of the exercise to start with. Let's go to the next one, Matt. But in the national context, our infrastructure is aging. We haven't replaced it much. Many of the systems are outdated. Some of the agencies we've talked to have to actually maintain a computer museum to manage their traffic signals. We've got growing congestion. These systems are growing bigger as the land use changes and as urban sprawl spreads. There's a funding shortfall. Everybody has seen that and felt that. Got less people, less staff, less money to do it. There's also no focus on system performance. When you ask them, well, how do you know when it's time to do a retiming? And they look at their watch and say, well, it's not 3 years yet. And they're not looking at how well their system is performing with respect to what do we need to do and how does that fit into the quality of the assets. But underlying those is that we've got no universal definition of state of good repair. And that term is in MAP 21. So we've got no definition to base our judgments on. Of course, few know the value of the assets they have. So how do you deal with that? Let's try the next slide again. Here's part of an exercise, if you can read this, that we did at a recent traffic signal operations review. And when we presented this, the folks kind of said, wow, they had no idea. And there's a lot of assets that we haven't even put in here, like the traffic signal timing investment is an asset. If it goes away tomorrow, you have to rebuild it, and you paid to have it developed to start with. Things like the communication network. The other stuff is many agencies have a fair amount of investment in stock on hand. You got a maintenance facility, you got maintenance trucks, you've got other items and tools that you're going to need to keep up. And then this column called Central is an interesting one, and you talk about these agencies in a region, and everybody's going out there and buying and building their own central system. But why can't they share it and save the cost of maintaining that valuable asset? If the bean counters got wind of this, you might have some trouble, because they'd say, well, why are we spending that for each city when you have one or maybe two and share them? Next slide, please. And let's talk about the term asset management. And here's the definition that comes out of MAP 21. And a key thing here is the state of good repair part of it. And without a definition of that, then we have a hard time maintaining assets to any particular level. So we, as the traffic signal operators, are going to have to define what that is, or you as an agency are going to have to define what that is to be able to identify how much do I need to maintain this. And if the funding drops, what do I not do to keep the system going? Next slide. And here I've highlighted it. Operating, maintaining, improving, the maintenance and preservation. Next slide. And here I get down to the state of good repair. That's the key here. That all supports that. But when we get to this and we look at all of those, the nexus of this in the middle here is really what we're talking about. You've got physical stuff, you've got the system stuff, and then you've got the people stuff. I mean, if you don't have the people, it's hard to deal with any of the other ones. They all have to work together and be at the same level of operational readiness. Next slide. So why is this important? I mean, we have to plan and budget to replace outdated items. Having traffic signal controllers on the street that are 20 years, 30 or 4 years old, and the manufacturer's been out of business for the last 20 is probably not a good thing. And we're not working to maximize the efficiency or the effectiveness of its resources. We've been, as we've seen in the traffic signal report cards, kind of doing this all ad hoc. But the bottom line is you need to support performance measures and goals through the asset management, or the management of the assets. Again, the influence of MAP 21. Here's what it says in MAP 21. That's going to be important to you, and you can use that as signal operators as a lever to say maybe we need to do a better job here. Next slide. And these are the MAP 21 national goals. And maintaining the assets at your disposal is important to meeting these national goals. If you don't have a working signal system, you don't have people to maintain it, you have a lot of stuff that doesn't work. We as an industry can't meet these national goals. Next slide. Again, the highlights is to ensure that the investments in the federal aid funds are directed to, where they really need to be. Let's make the best use of them. We don't get a whole lot of them, and it's important that we do the best with what we've got. Let's go. Next slide. Again, eligible projects. And, this MAP 21 and the STIP money can cover quite a broad range of stuff. And we're not taking advantage of it. And that isn't helping us any either. Next slide. So to kind of start wrapping it up, we've got no clear definition of good operations. And performance measure to test against the standard requires, in some cases, unattainable resources. And we have a reduced ability to retain, true experts. A lot of people go out there and they bid on things like signal timing, and they want the most they can get for the least amount of money. And of course, that's done by people that maybe aren't as qualified, and so the product that you get may not be as good. Bottom line here is we can't explain why we do what we do. Consider a scenario where your manager came into you and said, well, we're going to eliminate your whole organization. I mean, how do you defend yourself? Asset management might be part of it. Here's some of the tools available. And this last one, System of the Month, we're seeing a lot of them come on the market. Many of the tools that are here are nothing more than a inventory. A few of them link back to planning process for what we really need in the future. Next slide. So there's a lot of pieces again to this. And our role is that we need to pitch it that link it to performance management, link it to planning. We have to get beyond the simple inventory of stuff. Use financial and staffing planning. Approach for big and approach for small. There's different approach for different sizes and capabilities of agents. And there's probably some new tools and guidance that are needed, and we're currently working on an NCHRP project, I think it's 7-21, to try and develop some guidance and look at the tools of how to really do, the full asset management, not just small pieces and parts of it. I think we got one or two more here to go. And here's some websites that you might want to look at to help you with asset management. There's some training we have in developing program plans and performance measures for traffic signals, and you can find that on our website. Well, actually, it's not on the NHI website yet, but it's getting there. So I'm going to turn this back over to Matt, and we'll get on to the featured speakers.
All right, thanks, Paul. So next up, we have Mark Taylor from Utah DOT. And Mark, let me share your presentation. And you should be good to go, Mark.
All right, thank you. Hello and greetings from Utah. I would like to begin the discussion on asset management to let you know that for traffic signals, we at UDOT have not been very good in this area. In fact, we did a self-assessment last year and graded ourselves with an F. However, we are making large strides in this area and will have a productive asset management system in the very near future. Some brief facts about Utah. We are the 34th largest state by the population. However, by land area, we're the 13th largest state. 80% of UDOT's of Utah's population live along the Wasatch Front, which is an area about 100 miles long and approximately 5 miles wide. We have approximately 1,900 traffic signals in Utah, where 60% are owned and operated by UDOT. What makes us a bit unique is that all of the signals in Utah that are connected with communications share the same communications network. This approach has fostered a team-building environment with all the traffic signal partners where we work very closely with each other and share the same software programs. Next. The past experience of asset management for traffic signals in Utah has not been very good. What has happened is that unexpectedly a problem arises or information is needed. Maybe there was an equipment recall and you have little knowledge where in the field the equipment was deployed. Maybe the executive director heard about some unfavorable research report on the safety of flashing yellow arrows and wants to know when and where they have all been deployed so we can check our own safety studies. or just maybe you get, you get a new boss who has some creative idea that no one else has ever thought of, such as inventorying everything we own. Regardless of the problem, it is quickly realized that we have deficiencies in asset management. So a spreadsheet is quickly assembled and a summer intern is hired to inventory all of the signal equipment. For about 3 months, we know our assets. However, the database gradually grows stale over time, usually due to the difficulty of easily documenting and tracking when equipment is changed or updated. UDOT has unfortunately repeated this cycle at least 2 or 3 times within the last decade. So in 2011, UDOT's director decided that he never wanted to stop at a red light again. He asked, what would it take for UDOT's traffic signal operations to be world-class? A quality improvement team was created to answer that question. The quality improvement team process resulted in many great directives, including add a signal engineer in each region to help implement asset management for traffic signals, implement real-time monitoring of system health and quality of operations, use an asset management system to track equipment failures and to facilitate proactive signal maintenance, plan for long-term maintenance issues such as group LED replacement or upgrading traffic signal cabinets from the TS1 to the TS2. Lastly, to maintain an inventory of all pertinent traffic signal equipment. Next slide. We at UDOT recently purchased an asset management and inventory management system from Transcore and bought the source code, so we are able to develop it further on our own to meet our own specific needs. This system has 3 main purposes, all embedded into the same system, and it is still a work in progress. The 3 purposes are work order management, preventative maintenance management, and asset management inventory control. So the way it works is like this. If a technician gets a work order to fix something at a particular location, the system will also let the technician know while they are on the site if the intersection is due for preventative maintenance. While the technician is on site, the tech can also search for all intersections in a 5-mile radius where preventative maintenance is, also needed. Next slide. So we don't find ourselves getting databases full of stale data. How do you decide what to inventory and how to do it? There are several options, including manually writing down serial numbers, placing barcodes or the QR codes on equipment, or using radio frequency identification tags on the equipment. In doing this, you need to decide as an agency what equipment is worth the efforts for asset management and what is not. For us, we will keep track of controllers, MMUs, switches, power supplies, the cameras and radar detectors. However, we will not keep track of detector cards, load switches, or BIUs. Next. We have just recently decided through a research project we just finished that RFID tags are the best plan for our asset management program. RFID tags, as you can see from the picture on the bottom left of the screen, they come in many different shapes and the sizes. Some are more durable and weather-hardened than other tags. They are also attached either by a cable tie or self-adhesive. The way the RFID tag works is that a reader will energize the circuitry in the tag so it responds back electronically with its unique number. Smaller, the keychain Bluetooth RFID readers will energize the tag when within about 4 inches of the tag, while other larger readers may work 20 to 40 feet away. A big advantage of RFID tags is that they are able to read the tags in dark, dirty, and the tight areas such as traffic signal cabinets, where the barcodes are difficult to use. In addition, the RFID tags can be attached to the cameras, radar, and other outside assets, making it much easier for a technician on the ground to get. The Bluetooth RFID reader will interface directly with the AIMS asset management system using the tablets or smartphones in the field. The life of the tag is dependent on the amount of reads it receives, which is between 100,000 to 400,000 reads, and the costs vary, but between a dime to about the $10 or more each. Next. This is a snapshot of the asset management system we are developing, as it is still a work in progress. Traffic signals can be selected via a map or drop-down list. You then select the equipment to scan. As you click scan, the RFID reader is activated. Next. We recently developed a system health monitoring program that will show the communication status of all of our IP addressable devices in the field. If the ping status is good, it shows in the green. If it is good and intermittent, it shows in light green. If it is failed and intermittent, it is in yellow. And if it is failed, it shows in red. The system health monitoring program will interface with our customized asset management program, where if the device is failed and has been in a failed state for, let's say, 3 or more days, it will generate a work order automatically. Next. U.Dot considers mobility an asset as well, and one that we need to manage. We are currently doing this through a website that shows real-time traffic signal performance metrics. The site is located at u.traffic.utah.gov/signal performance metrics. We have several performance metrics in use that show the quality of operations for traffic signals. One such metric shows, next, the progression quality of vehicles arriving at a continuous flow intersection at Bangor Highway and 5400 South in Salt Lake City. Are vehicles arriving on the green and red, and if so, how many are arriving during the green? The x-axis is showing the time of day. The y-axis is showing the cycle time. The black dots are vehicles arriving at the intersection. The green line is showing you the start of the green phase. Underneath the green line are vehicles arriving during the red phase. New signal coordination plans were installed on this day. Would you mind advancing it? 3. The new offset for midday, the coordination plan was incorrect, about 180 degrees backwards from what it should have been. The problem was quickly noticed and corrected just before noon. You are able to see that for the midday plan, 56% of vehicles arrived during green on this day. Next. And then next again here. If we were to look at the same intersection and same approach on September 12th, after the offset was corrected, you are able to see that we now have the 77% of vehicles arriving during the green for the midday coordination plan. Next. Another metric we have shows how the phase terminates when the phase changes from green to red. Does it terminate by a gap out, max out, force off, or is the phase skipped? We also show the pedestrian activations in orange just above the phase number on the y-axis. The x-axis is showing the time of day for Tuesday, April 16th. For example, at this location, located at Green Springs Road and the Telegraph Street in the St. George, Utah, you are able to see that there is a constant pedestrian demand on phase 8 until the technician repaired the broken pedestrian button just before 1. Part of our asset management program will include alerting us when we have equipment failures, such as the constant pedestrian or vehicle calls in the middle of the night. Next. This metric is showing us approach speeds for the northbound direction at an intersection along Riverdale Road in Ogden, Utah for January the 10th, 2013. The green line is showing the posted speed, while the red line is showing the average speed, and the blue line is showing the 85th percentile speed. You are able to see from the chart that a snowstorm came in at 3 p.m. that caused a large drop of vehicle speeds. The chart is also helpful in determining if and when snow plans should run, as well as being used to properly set the yellow and red clearance intervals. Next. The picture on the bottom right of the screen is the RFID tag we will be using for devices within the traffic signal cabinet that will be attached using the cable ties. It is the 2 inches long, 3/4 inch wide, and about a fifth of an inch in the thickness. Its maximum read range is between 13 feet and 26 feet if it is on metal. The RFID tag will also have a barcode on the front, so if the technician does not have a reader handy, they are able to use the smartphone app and scan the barcode. The cost for the tag is about $3.50 each. For outside assets, the RFID tag will be 4 inches long, 1 inch wide, and about a ½ inch in the thickness. And its range will be between 20 feet to the 40 feet, so you should be able to read it while you are on the ground. The cost of the tag is $4 each. Thank you for your time. If you have any additional information, please send me an email or give me a call. Thank you very much.
Thanks, Mark. And again, if anybody has any questions for Mark, please type them into the Q&A feature within Live Meeting, and we'll take care of those at the end. So next up, we have Peter Kuntz from the City of Portland in Portland, Oregon. And Peter, let me get your presentation up here, and you should be good to go.
Great, thanks, Matt. So we always, in the City of Portland, we always like to say that we look to be second in line after somebody else pioneers a particular activity. And Mark at Utah DOT, they've been doing a lot of things that we've been watching very carefully to see if we can adapt some of the things that they're doing for our purposes. And so I like to say that it's one of those things that these sorts of webinars really, you get an opportunity to get a sense for what we can do, how do we base our decisions and our choices of what we're going to invest in on what others are doing. And that the example that he used in terms of having TransSuite pull up the system is something that we're going to look at very carefully. With my presentation, I want to talk about what we do at the City of Portland, just give you a quick overview of that, talk a little about our story and how we've been looking to innovate as a way to solve some of these problems. I start out my discussion with looking at us as signals and street lighting, which is my purview, as it relates to other things. And, of course, why we haven't done much in traffic signals, why we're just doing that now, is because as an asset, we're not as big as pavement, of course, and so in bridges. And so if you think about it from the context of this, that we're only about, $500 million of the $8 billion system that Portland has to manage. I will say that the traffic signals, as we went through our community process, we were ranked as the #1 budget priority because of the notice that people understood that they were a key part of the safety of people throughout the city. So as a bureau, as a group, when I got here in 2009, we were 47 people. Now we're down to 40. And that's something that, I think is a story that isn't just unique to Portland, but we are getting smaller as an agency. And so trying to figure out, it's the old adage of how do we do more with less. Can we do more with less? No, we probably can't do more with less. But at least we can do better with what we have and trying to harness technology. I'll talk about that as a part of my presentation. What ways have we looked at delivering the services more efficiently, more effectively? So part of that is in the numbers of the making sure that the people are more effective, but then also making sure that we're cutting our budget where we can, and the power bill is a part of that. One of the assets that is overlooked is the team, and so this is my the group way before I got here. It's circa 2001. There's a really good amount of pride within the team at the City of Portland. One of the reasons I use this picture of folks from 2001 is you'll notice in the room there aren't any computers there, and so that's really been a transformation that we've been working on. We now have apps on our phone. We have cameras in everybody's pocket that gives us an opportunity to get better information from the field to our engineers on staff, and it's under my purview to do both the maintenance and operations, not only the folks that are out there changing light bulbs, but also the people that are designing and planning for our system. So the assets, of course, it's not only just the things that we have, it's also the people who do the work. And so the people really do matter, and what's more important is that the engineering staff that are working with the maintenance staff, to making sure that we have an effective relationship there and that we're building a better system. We're getting feedback from maintenance so that we're not creating the same problems that they have today. So it gets down to workforce development at the end of the day, knowledge, skills, and abilities. You've probably all heard about those terms, and so we constantly have to look at what are our proficiencies, what are the needs for training, but then also where we might need redundancies. If we are a smaller workforce, where might we want to think about how we partner with our private sector partners, that if somebody does retire, that we're not completely out of luck in terms of maintaining the equipment that we do have. As Paul mentioned, some of this equipment is archaic, and so how do we do our little best to work with what we have? So just to give you a little sense for what the maintenance operations in the city of Portland is responsible for, we have over 1,000 traffic signals, over 10,000 streetlights, and then communications cables. So as Paul said, you know, we've done a reasonable job of inventory in our system. We haven't gone to the extent and the lengths that Utah DOT have, but we do have a picture of what are our various elements that are part and parcel to what we are doing. Part of the importance of that, at least having that inventory, is then being able to look at the priorities and identify what are the things that we're doing as a group, and if we are going to change things, how might we do that? What are the trade-offs that we have to make in the field so that we're doing a wide variety of things, but doing them better? So part of that is signal relamping. Of course, as we've implemented things like LEDs, we've found that maybe that response that we've had to spend a lot of time on, maybe that becomes less in the future because the equipment is more reliable and gives us a less work to do. And so we've been really looking very carefully at the things that we do and tracking how those things are affecting the way we're doing things. And so there's some really good stories to be told about the equipment that we have and the response. Part of that, though, of course, is whatever we do, we end up with things that get hit in the field and things that get broken. And so one of the things as we've gotten leaner in terms of our capital budgets is we look at things that get hit and crashes that happen as opportunities. So in this example is a damage to a pole. We'd love to replace that pole, but the costs are just not there. We don't have an assailant in this case. So one of the things that we've strived to do when we have those sorts of crashes that happen is trying to figure out how do we make a system that's better and replace the system using insurance that's out there in terms of the opportunities that exist. So we've done a good job of asset management by age. That's of course looking at it from a neighborhood district in Portland and looking at the age of the equipment. That's a basic level to look at. And then we can chart that over time if we think about the condition rating. And so this is just having the street lighting condition. The bad news, if you look at it over time, is that we're getting less good because we don't have the capital resources in place. So if you click the next slide, you show the trends are not in a favorable direction. So the percentage good is in the wrong direction. The percentage poor is growing. And so overall, we have a downward spiral, if you will. But that's something that, you know, you have to tell your story with asset management. And you can start out with that age of equipment out in the field as a way to tell your story, similar to what the folks in pavement have done for years. We can also lay that on top of risk, and so that's where, as Paul mentioned, and Map 21 infers, is that you should be focused on risk and prioritizing, and so we have done that in Portland. We have looked at the age of the system and relayed that back to where we have the most risk. So we have high crash intersections, we have school zones, and we have transit and freight routes. So all those, this matrix essentially helps us prioritize where we might do our improvements and where we also might improve our response. You could think about these sorts of high crash locations and transit routes as important to make sure that we're responding quickly. And the other ones that are not on the list is maybe we could let, if it's not a high traffic area, maybe it's something that we don't have to respond to immediately. We could maybe let that signal be in red flash on the Sunday night. It's not as important because it's not carrying as much traffic, so maybe we respond to it during the normal working day instead of doing it on an overtime basis. So we've done that with our risk. We have these sustainable levels of service. And one of the things that we introduced, we've always had the system condition. We always wanted to know if the hardware is in fair or better condition. So that's our target's 80%. Now, whether that's achievable is a debatable topic. But the new metric that we've used is percentage of signals without outages. So trying to figure out how we're doing in terms of the safety that's actually on the street. Is the signal going into red flash repeatedly? And so you can see that that's a new measure, but it's based on the information that's coming from the signal system that's telling us whether the system is operating, whether it's in red flash for those that we have online. We can figure that out and incorporate that as a measure for our asset management. So one of the other aspects that of course, signals is a big part, and ITS is a big part of what we do, but Streetline is also an element. So I just wanted to highlight that as a key opportunity that state DOTs and others should be looking at. And one of the things that we're doing is exploring LEDs. And so you've probably heard a little bit about that, but also adaptive lighting controls. Maybe we could do some dimming. So the example that I used as part of my budget is the $13 million, $60 million of that is the electricity bill for lighting. And so, next slide, please. We're looking at LED technology as a way to reduce our power consumption. We see the opportunity for implementing LEDs and reducing power by 40 to 60%, depending on the location. But then also reduce the maintenance cycle from the streetlights from 5 years to 20 years. So we're excited about that opportunity as well. And click the next slide. So the other last thing I'll leave you with is business processes. It sounds like Mark has been working on this as well. We've been just trying to get out of that paperwork realm and improve the data when we go out into the field. So the next slide shows you our maintenance logs. So we had an intern, as Mark said, doing some of these maintenance logs entries, and we had a really particularly smart intern where he said, well, gosh, I could just take these and turn them into an Excel spreadsheet. Instead of doing timesheets like this, we should just have an Excel spreadsheet. So very quickly, he got into the Excel and said, boy, I can do the exact same thing, put it into Excel, and then figure out if we can implement that Excel spreadsheet with the maintenance staff, and then in doing that, upload that into a GIS format. So if you go to the next slide, one of the things we've added onto the timesheet is to pull out that middle column. Actually, in every column is actually asking the maintenance staff to do an inspection of the cabinets and to rate those cabinets and controllers and poles and signals, rate them on a scale of 1 to 20. So we're doing, as they go out to do an intersection repair or any response, we're asking them to look at things and update things and see if there are things that have changed since we've been out there the last time. But it's really, part of that is, and then uploading photos is a part of that. If there's something to respond to, then how do we get information so that it's in the hands of the right people and having that go from one look at it to then an improvement that we go and implement in the field. So it's trying to get technology in the hands of the staff that are out there in the field so that we can improve our practices. So to wrap up, we've worked on workforce development as a key part of our element, making sure the staff have the technology in their hands so that they can improve their practices. We've looked at risk as managers of the system to try to put an emphasis on safety and explore energy efficiencies that help our bottom line. And then finally, to change existing processes, to try to look at what we're doing and see if we can't do things, really do more with less by just introducing simple things like going from paper to electronic time cards. And with that, I'll conclude. Thanks for the time.
All right. Thanks, Peter. Again, if you have any questions for Peter, use the Q&A feature and type them in, and we'll address all the questions at the end. So next up, we have Van Loan Nguyen and Mark Hagan from VDOT. And let me bring up your presentation here real quick.
All right. Thank you, Matt. I appreciate it. Thank you, everybody, for the opportunity to share what we're doing at VDOT with the signal management program. It's exciting. I want to second Peter's comment about this opportunity to learn from each other. We at VDOT, although we have a big agency, we really don't have an enterprise tool to do a lot of the performance measures and the tracking of the asset consistently across the state, like some of the other smaller DOTs or localities. So this is an opportunity. It's great to see some of the options out there for us. For this presentation, we want to touch on our framework of managing our signal system as a whole. We're really looking at what Paul had said before. It's really looking at a whole life cycle of traffic signal management, going through from planning to construction to operations and maintenance, and all within the framework for asset management, and then link that all back to more of a global vision of mobility and health of the system and such. So we'll touch on the lifecycle management, asset framework, and mobility decision support as we go through the presentation. Next slide, please. I think all of us share the common knowledge that it seems like traffic signals or other assets are really secondary to a lot of DOTs. Pavement bridges seem to have their priority because they are a financial investment really out there. They do have a lot of performance measures already and system already and tools to provide the asset management framework. So we really chosen the MAP 21 requirement and the encouragement to expand that into other assets to just put the focus on signals. Next. This is just a snapshot from Virginia. VDOT we're really the third largest roadway network in the U.S. Within that, we have 5 traffic operations centers and approximately 3,000 signals. Not having a centralized enterprise system out there, it's really difficult to do on a day-to-day basis to know what our inventory is. We have 5 operations centers or 5 regions that oversee 9 construction districts. And some regions are much more advanced in their management of the signals. Some of the others didn't really have the tool to track the inventory. We have done sort of a cursory asset value replacement, and we estimated approximately $1 billion replacement value for the 3,000 signal lights in the section, inclusive of some of the hardware, software side of the house, communication systems, central systems and such. So this is just from an asset management context, we just want to be able to present that this is really not a low volume, low value type of asset that Virginia owns. So there's some attention really needs to be paid to that. Next, please. So since 2006, VDOT has migrated to what we call a needs-based budgeting approach. So that it's a dedicated maintenance operations fund from the state annual budget. This is a General Assembly requirement for us to report on an annual basis on what we do with those funds. So historically, we just gather historical expenditure and estimate the needs going forward. In 2006, we started migrating to more of a data-driven type of needs-based budgeting or budgeting process. As I said, the pavement bridges already have the information. It was very challenging to do it for the other assets, including signals, because we really didn't have a cohesive set of data from inventory to cost data consistently across the state. Next, please. However, with that approach, we still have we developed a needs-based modeling for the signals. It's really comprised of different components of management of signals, including preventive maintenance to construction to operations to resource allocation. So and we did the model really more of a snapshot in time. It's not a systematic methodology that we collect data real-time consistent across the state. But it does provide a framework for us to advance, to advocate for the resource allocation for the signals. As you can see, FY11, FY12, and 13, there has been an increasing trend. However, it's really not live data per se. So every time there is financial remodeling of budgeting processes, it's very challenging for us to shift gears and justify our needs. So next please. So in 2011, we decided, you know what, we really do need to start telling our story better. But first, we need to know what is it that we have. So in 2010, 2011, we conducted the signal on our signal system. And we looked at more of a holistic process of managing signal as a whole. We're looking at from the planning, the operation side of the house, all the way to the construction, maintenance, and the life cycle funding, budgetary aspects of it. So with that effort, there was over 100 recommendations to addressing those various components from engineering to staffing resource. And one of the key things that came out of that is really the database management practices, because we determined that was, data is what we need in order to manage the program appropriately and advocate for the resource allocated to it, and then be able to justify the funding allocation that was, I guess the bigger question is, what are we getting for what we're giving you? So those kind of things that of upper management continually asking, or of legislators, every time annually there's a General Assembly session, there's always a question that comes up that we'd have to be able to defend that. Next. Okay. So what came out from some of those recommendations was a need to have a COI, which is the communities of interest. And as you know, the traffic signal is a pretty complex asset within the traffic arena, and it touches so many stakeholders. So this COI is really an approach to bring together various different stakeholders across the department, from designers to construction engineers to maintenance engineers to budget and IT of all, because we felt that we have to migrate to more of a technologically advanced process in order to manage our system. So the COIs was created, and it was tied back into a higher level of 2008 data business plan as an agency that we have developed. Next, please. So the COI had determined that there are, as I mentioned, that we don't really have an enterprise system statewide for the 3,000 signals across 5 regions. So there is a various different aspects of data set that we use in order to compile it at a statewide level. So part of that assessment, until we have an enterprise system, asset management system, is to identify all the data elements and then determine how can we utilize it and reporting out consistently. So one of the recommendations is the data model, the data management, and it's really because of what it will do is it will consolidate a lot of the data set out there that was not I guess readily available or integratable into a repository. Matt, could you advance one more slide?
Yep.
Thank you. So there's many transactional systems out there that we use right now. We have a homegrown ATMS system, which tracks really work order. There's one district uses Micromain, another uses IMMS. There are various spreadsheets, databases. And then we also had roadware data. In 2009, we actually did a statewide inventory of all the assets just to give us a snapshot in time of what our data set is. And so we have all these data out there without really a system to integrate them all and be able to report to and looking at more of a global picture. So the data mart is an effort to centralize all that, put it into a central depository, and then either go to a data mart for reporting purposes, or in the future, we'll also, if we have an asset management system, enterprise one, then we can incorporate the data set into that. Next, please. So without the tools, without I guess the system in place, staff will innovate. I mean, they will go through and say, okay, we still have to do more with less. VDOT had transitioned from about 10,000 plus people about several years ago down to 7,500. So a lot of it, we have much more less staff to do the work, but yet the system is growing daily. I mean, that's why it's approximately 3,000 signals. We have one region that's adding 100 per year. So on an annual basis, it's just increasing significantly. And then the other challenge for us was really the philosophy of the agency. Upper management went through several IT initiatives recently. One of them is our financial system, conversion from one system over to the other. So they're really leery of any new system out there. So the enterprise asset management system gets secondary support from them. And then in addition to that, there was the perception that we are collecting data just for the sake of collecting data to manage our assets. That's not effective. So when we don't have the support to get the tools for us to deliver our business more efficiently with reduced staff, and then on the other hand, there's also the perception of data collection. So we figured that is there a way to capture the data as part of how we do business? We are going out there to touch a guardrail or a sign or signal. As we go about doing that, are there tools for us to capture the processes or the information, the data set without, the idea that we go out just to collect data. And then, of course, we don't really have the asset management system tool to do that currently, so we have to innovate. And part of that is really to create an app, a mobile app to collect it's really an engineering assessment of the guardrail. As we go out there, we do assessment of guardrail needs, and then we develop a mobile app in which to collect all the asset data as part of that. So that's one of our initiatives that we are going to expand out to the signal as the next phase. Next phase. Okay. This time I'm going to turn over to Mark Hagan, who's the Northern Region's Regional Operations Manager who championed this effort.
Well, good afternoon, everybody. I've enjoyed, what I've heard so far from Mark and Peter and Paul and Matt. Matt scares me because I was telling Van that everything he was saying or discussions that Van and I have had over the last year, and now we think our rooms are bugged by Matt. At least that's what I think, because it was almost everything we've talked about he mentioned, and every flaw that we have he mentioned. It was kind of weird. But anyway, I guess for me, and what I want to talk about, the DOTs for years were never a data collection agency per se. It was you had a budget, you had to spend it, and of course, data collection programs were, they're not that expensive, so it really didn't affect my budget if I was trying to get to within 1 or 0.5% at the end of the year. So what's happened with my group, which is more of a boots-on-the-ground type of philosophy, convincing them how important data gathering was, that helped me, as Mark and Peter were talking about, sell the story so I can go after resources, I can go after personnel, and I can track what I have out there for lack of a better way, for the life cycle issues and the needs-based budgets. So there wasn't really a lot out there as far as data collection systems. As Van said, each region had its own way it did things. Each area had its own, spreadsheet development process and access database development process and whatever systems that they were able to procure behind the scenes that they used that worked for them. So I sat down and I just listened to all my counterparts, what they have, what we were doing, and what we need to do. And I just got lucky. I have a guy that works for me that he worked towards his master's degree in programming. And I sat down with him, and we were trying to figure out what methodology and what could we use that could gather the data I need to sell my organization to upper management to increase budgets and stuff. And what we concluded was we needed a web-based system. So we sat down and Van talked about the Data Mart group. So I was involved in that, and I was able to find out where we were going to head as far as the asset collection that was going to be needed by upper management. So I had kind of an inside track on that. So we developed it, which had the field data, the repair data, the communications data, signal construction data, and within that, we were able to capture and are going to capture signal plans and foundation data, which I'm sure everybody has always had an issue with keeping that in a repository where you could access it when needed. And then, of course, that helped me develop life cycle data and costs. Then what I did was, like everybody else, I now have this data and it's useful, but what can I do with the budget of want you to do more with equivalent. They didn't really cut me, but we keep building, like Van said, 50 to 100 new signals a year, and, you know, my budgets aren't increasing at this time, so it's more with equivalent. So I tried to figure out, was it overtime that was killing me? Was it other, you know, repair costs that were killing me? And I'll give you an example of what the data that we started to collect and how it's going to work out for us here in Virginia was on all the work reports, it was replaced cable, replaced cable, replaced cable. So I didn't know if I had rodent problems. I didn't know if, you know, the cable was at an age that it was just naturally going to fail, so on and so forth. And after about a year's worth of data collection, I found out that about a third of my cable plant problems were they were being cut by different utilities out there. Virginia the Virginia DOT is not part of Miss Utility, and that's the statewide cable marking program that the power companies and the telephone companies utilize. By law, we could not be a part of that. So what we're doing now is developing our own utility marking and locating program. It went online last week, so we're going to start spreading it out through the construction areas, and we've talked to Miss Utility, and they're going to put our link on their website. So right now, I'll probably, this year alone, because of this program, save a couple to $300,000 in cable hits. And now I'm starting to collect data on fiber hits. How much am I going to save there? So that's the data management systems for traffic signals. It's important knowing where assets are, how many we have for the life cycle stuff. But there's an ancillary benefit that I'm starting to see is things that I never looked at before that are going to end up saving me money. So anyway, I'm going to turn it back over to Van. That was my story. And
thank you, Matt. I know that we're running short on time, so I just want to touch on this quickly. The Virginia recently had outsourced a lot of our ITS, actually our Transportation Operations Center, all 5 of them out to one central contract. And that's mostly just the ITS asset, excluding signals. There's an opportunity to expand on that in the future, and they are using Maximo. So there's light at the end of the tunnel for us that we might get an enterprise system in the near future. Next slide. Next slide that just really captures our justification why we need an enterprise system to manage the whole life cycle of our program, from budgeting to work management to disaster recovery. Next one, please. So this might be an interesting thing. You know, we talked before with the other presenters on how to market our programs and how to be at the table. So this is VDOT's version of how we want to compete with the big gorillas, with the pavement, with the bridges. Those have condition rating and structurally deficient categories and such. So we had come up with sort of what we call an intersection sufficiency rating for signalized intersections that really consider those risk factors, those goals objective on congestion, the asset condition, age and technology and such. So under those categories that we outlined there, we're going to be arriving at a sufficiency rating for each of those signals. And so hopefully we'll be at the same table, with the pavement bridges and identifying the cost associated to replace that asset. So that's our way of selling it. Quickly on the lessons learned, I think we touched on this before, linking it to global vision. We had, and the legislators keep on talking about mobility, finding alternative routing for congestion on the freeway. So linking that back to that, linking to the recommendations for MAP 21. We found out that anything that we want to do here, that we want to have a system replacement or funding strategy, we really have to have an executive champion, and then, of course, field buy-in is really critical because they are the people that are actually going to deliver the work. Technology certainly is something to consider, and then marketing, selling it to. And I think I'm glad to see some of the information that Peter and Mark had shared because there's better ideas for us to market ourselves that are coming forward. And the nice thing about it is that Virginia recently got, in the first time in 27 years, we did have a dedicated funding source for transportation, of which 5% of it is dedicated for smart technology, which is ITS and signals and such. So hopefully we'll have some sustainable funding going forward to managing our signals as a whole. Thank you.
All right. Thanks, Van Loan. Thanks, Mark. So with that, that's the end of the presentations. Now we have some time for any Q&A. I just want to remind people to use the Q&A functionality to type in your question. It's the easiest way to sort of manage questions. And we are going to have a recording of the webinar available at tam.transportation.org, as well as the slides that you can download if you want to get the actual slide presentation. So I don't see any questions yet. There we go. I have one from Rita here. Oh, the NCHRP reference that Paul mentioned. I think that was NCHRP 721 or 722.
I think it's 7-21.
Okay.
And it's underway. It started. The contractor that's doing it is VHB out of Boston. There's additional funding that's going to be added to it to specifically look at signals, and that will happen sometime early next year, maybe. But you'll see some results from that here before too long.
Yeah. And you can find the status of all those NCHRP projects on TRB's website. All right. So we have one from, I guess, Carmen Televra. My question is in regards to procedures in place for replacement of traffic signal standards that are damaged as a result of a collision. Do you place them right away, hire a structural engineer to assess conditions, and then decide? This is provided the pole is still standing and has noticeable damage to the pole structure. So I guess Peter, that was question came from your presentation. So did you want to address that, and I'll open it up for the other people as well?
No, I don't want to address that.
Okay.
I'm just kidding. Because it's a hard question. We do have structural engineering staff that will take a look at things, but a lot of times we don't even know the poles are hit. We do our annual inspection, so its average time is 6 months in between if they're not reported as a crash. If somebody just rubs the pole or a truck just hit the pole, unless there's damage to the pedestrian indications or something of that matter. So that's something that those clearly don't meet our standards. Clearly don't meet the new AASHTO standard. None of our poles meet the new AASHTO standard, and so really, in any case, we would have to replace the pole. So that's our challenge, and one of the things that, of course, we have debated a bit with our state DOT structural engineers about, because they, anytime you get to those conversations, you end up with the structural engineering trying to meet the letter of the law, and us understanding that we just can't in many cases.
I guess Mark Taylor or Van Loan or Mark Hagan, do you want to address it from either Utah or VDOT's perspective?
I'll let Mark do this.
Yeah, we use number 2. Our structural engineer will come out and they'll deem it whether it's critical in nature and needs to be replaced. And I keep a certain amount of funding within my budget for those types of emergencies. Usually I have enough money sitting there for about 10 poles if they need to be replaced where they've been hit or damaged or some sort of structural defect's been found. And then, of course, the last couple months of the year, if I've only replaced 1 or 2 poles, I'll spend that money on something else that's needed within my area.
Okay. And Mark Taylor, do you want to add anything to that?
No, we are doing the same that Virginia and the Portsmouth's doing, where we have money, so if the things get knocked down, we'll go out there and get them fixed. We will just use some engineering best, the judgments out there to decide if it's worthwhile to bring in one of our structural engineers to actually take a look at it. But if that is the case, yes, we will replace.
Okay. I think Paul just raised his hand. Did you have a question, or do you want to add on to that, Paul?
Yeah, I wanted to add a comment to that. In that, in our signal reviews, we talked to an agency that said for pole replacement, they couldn't, or they're banned from replacing a pole until it actually fell down. So you guys that are actually looking at it are probably doing a lot better than some.
Yeah. All right. Here comes another question came in. Are there any plans to use upcoming technologies like DSRC to collect data from traffic controllers, to collect phase data and check if the controller is working fine, working okay?
I'll jump in there and say absolutely positively not yet. That's the first we've ever heard anybody talking about it in those terms, and we would want to save DSRC for safety things rather than inventory kind of a thing. So most likely not at this point.
Okay. Anybody else want to add on to that from the panel?
I would agree. We'd rather use our existing traffic signal system to do that sort of thing.
Yeah, in Virginia, we'd rather do that too. We actually only have one centralized central system in Nova, which is half of the population of the signals. But if we have a preference, we will use our system.
Okay. Any other questions from anybody on the webinar? See, nobody's typing, so we'll go once, going twice, going 3 times. I guess first I'll say thank you to everybody for joining us today. Again, the recording and the slide deck will be available at tam.transportation.org. I want to throw it back over to Steve Gay if you have any other closing remarks.
I think Steve might have had to head out early.
Okay, I guess Paul.
That was part of the federal shutdown.
No, not FHWA. They're fine.
No. But this is Joe Greger of FHWA. I work with Steve and Paul Olson.
Okay.
Again, yeah, I'll just say thank you, and also one of the reasons we put on webinars like these is because we just want to hear feedback from you all as far as what we on the FHWA and AASHTO side can do to help provide any assistance or resources specifically for this. So if you have any comments or suggestions, just feel free to send it either my way or contact Paul Olson or Steve Gay. So with that, I'll turn over to Matt.
All right. Thanks, Joe. I guess with that, we will call it a day. Hope everybody